Hi, good day. I am Fatima Salidaga, a BSEd major in mathematics student of Kapalan College of Agriculture, Sciences and Technology.
In this video, I will help you learn and solve a linear programming model using graphical method. But first, I will introduce to you the LP model in using graphical method. Graphical method of linear programming is used to solve problems by finding the highest or lowest point of intersection between the objective function line and the feasible region on a graph. Now let's solve a linear programming problem by maximization. What we have here is an LP model. We use x and y as our division variables for quantity of what we buy, produce, sell, or transport. As we see in the problem, the z is equals to 3x plus 2y is the objective function we want to maximize. The next equation are called constraints. And this last part of the problem that tells us that the both x and y has to be greater than or equal to 0 are called non-negativity constraints. Let's have the solution for the problem. For the first constraint, if x is equals to 0, then y is equals to 18 with a point of 0 and 18. And if y is equals to 0, then x is equals to 9 with a point 9 and 0. In the second constraint, if x is equals to 0, then y is equals to 14 with the point 0 and 14. And if y is equals to 0, then x is equals to 21 with a point of 21 and 0. For the last constraint, if x is equals to 0, then y is equals to 24 with a point of 0 and 24. If y is equals to 0, then x is equals to 8 with a point of 8 and 0. Now here is the graph. Since the constraints are less than or equal to constraints, they will be satisfied in a region below the lines towards the origin. The region satisfying the constraints is the shaded part here in the graph, which is called the feasible region. A feasible region is the intersection of the regions defined by the set of constraints and the coordinate axis, condition of non-negativity of variables. To decide which one is optimal, we will find the coordinates of the point. At the corner point A, the coordinates are 0 and 0. At B, 0, 14. At C, 3, 12. At D, 6 and 6. And at E, 8, 0. Now, let's solve the maximization equation, which is z is equals to 3x plus 2y. To solve the points, we have A is 0, B is 28, C is 33, D is 30, and E is 24. Therefore, the maximum optimal point is reached. Z is equals to 33 at the corner point 3 and 12.